Hello, I'm Steven, and today me and Trent are going to introduce you to the programming language Lua. So we have a good amount of material to cover. Trent's going to get us started with an introduction and overview. Then I'm going to go into versions, users, and dialects. And then finally, I'm going to conclude with a bunch of specific coding examples.
So Lua got its start in 1993 at a research lab in Brazil, where engineers needed an easier way to handle repetitive tasks while building tools for a company with lots of legacy systems. They started with two custom languages, which were small, but those languages didn't go far enough. So the team built Lua as a more flexible scripting language. Lua was created by a three-person group, which kept the language focused and concise. The real users from day one helped shape Lua with their feedback, and as time goes on, Lua has remained relevant, powerful, and useful. So what exactly is Lua? At its core, Lua is a scripting language that's both lightweight and embeddable. It was designed to be included inside other programs, especially where performance and portability matter. Lua uses an imperative programming style, meaning it's based on statements and control flow, which is of course familiar to anyone with knowledge of languages like Java, C++, or Python. It's dynamically typed and it's also interpreted by default, but you can compile Lua to bytecode with the included Lua C compiler if needed. But one of Lua's biggest strengths is how simple and approachable it is. Its minimal syntax means there's not much to memorize, making it really beginner-friendly. Lua's readability is also extremely nice when working on collaborative projects where understanding others' code is a key to effective development. Lua doesn't try to do everything, and that's what makes it so powerful and useful for embedding. We get into some more specific examples later, but this is to look at Lua's syntax and core features. This script shows variables, print statements, tables, conditionals, loops, and functions. Once again, Lua uses dynamic typing so you can see the variable types aren't declared. The first three variables at the top of the script are marked local, which limits their scope, similar to private modifiers in Java or C++. By default, variables in Lua are global, like the score variable. The function greet towards the end of the script is also global, but our code editor gives us a warning because global element names are supposed to start with a capital letter. This doesn't stop the code from running, but it does help avoid scope-related bugs. You can see with the loops and conditionals, Lua uses then, do, and end keywords rather than brackets, creating some nice readability. At the very end of the script, we can see an anonymous function assigned to a variable. This acts like a lambda in other languages. All functions can be stored into tables, just like this one, but we will dive deeper into tables and more features after we cover some more background on Lua.
Getting into the different releases and updates of Lua, it's definitely seen a good fair bit of changes over the 30 years it's been around. And I think this timeline can just quickly show all the additions that have been added at various different points in time. So as you can see in Lua 2.1, about 2 years after the language was created, object-oriented programming support was added, which is done through tables. And then Lua C, which was mentioned, was added. Pattern matching, anonymous functions, functional features. And then continuing on into the 2000s, there was a lot more updates. Once again, for loops added in 2000s, threading meta tables, which are used for object-oriented programming, replaced an earlier feature that was used for that. Integers were added in 5.3, which sounds kind of crazy, and we'll actually get into that a little bit later. And then 5.4, the most recent version of Lua, still being updated right now, and getting into all the different companies that are using Lua, or not just companies, but platforms and whatnot. And going from top to bottom, kind of smaller use cases to more integral use cases. So, for example, Wireshark, simply to create prototypes, like users are able to create prototypes for various different networking tasks. And same kind of similar with NeoVim, you get some config options that are very easy just to edit. And then going down, like Roblox has a complete different version of Lua that they developed over time to create their own features on top of Lua that actually supports and is catered to their own game engine, basically, where you're able to script in a dialect of Lua, similar with Gary's mod, and then Love 2D is basically a framework built around Lua. And then speaking of dialects, Lua U is actually the one I was just talking about with Roblox, and then you see Gary's mod, Lua. But the difference between compiles to Lua versus dialects of Lua is that languages that just compile to Lua, typically they're going to have modified syntax, usually drastically modified. And the thing about compiling is the modified language compiles into the Lua's source code. So you're able to interpret it all the same once it's compiled. The difference between that and the dialects of Lua is that the dialects of Lua have to have their own interpreter. So the languages are basically variants, once again, of Lua, where developers create their own custom interpreters as well as language changes. So it's kind of similar, except you can't use the same interpreter that Lua provides. But continuing on, let's get into some examples. So first example is types. So it's going to be pretty standard. Everything looks pretty similar. We could go into this actual code and to look at it. But so there's a number type, there's a Boolean type, a nil type, which is null, and then a string type. So, and then outside of those four main types, there's table, and then there's some additional types like, let's see what these are. So if we go down, we can see first type is considered a number, second type, Boolean, string, nil, and then here we go with table. So it says it's a table type, and it actually returns a memory address. Same with the user data. This is considered a file, and it returns memory address and a thread. So, and then a function. So those are the basic types of Lua. The interesting one really is number. So like earlier I said, they added integer very late in the development, and that's for a specific reason. Numbers were completely defined at one point by strictly floats. But if we look into the more recent versions of Lua, you can actually see how numbers are defined. So if you see in the code, we have typically this would be considered an int, and this would be considered either like a double or float in other languages where you actually declare the values. But here, they're both considered numbers when you use the type. But continuing down, if we use math type, which was added more recently, you can actually see that there's a difference whenever you use math type. There's an integer and a float. So, and then continuing down, you can see the two are equal regardless, similar to C++. I believe this would be due to implicit type conversion. And yeah, I think that's just an interesting aspect of the number type. But anyways, continuing on past that, here goes a big screen of a bunch of text. And this is tables, which is, I would consider Lua's catch-all data structure. There's no array, there's no list, none of these data structures are like simply predefined because the table can be them. So we can continue on to the tables. And there's not too much to look at here, but I mean, there's a lot to look at here, but really you can get the gist that these are all acting as the different various structures that you would see in other languages. And if we run it, it'll really just give us this output that you see right here. You'll notice the one indexing right here. This pulls Lua because it's a one index language. And yeah, it's a lot of stuff you can do with the table, which includes using them for object-oriented programming alongside metatables. It still looks like pretty basic object-oriented programming, nothing too unfamiliar. It's just all done with this one table data structure. But there's a few things to point out here. So you can see the new function acts as the constructor, and the purpose of the object and setting it to metatable in the constructor is to allow this object to have access to all the defined functions. And alongside that, there's the self index, which makes sure that if a method isn't found on the object itself, Lua looks it up in the account table. And then beyond that, there's two methods that are declared in different ways, so they're used in different ways, but they're really equivalent. It's just a syntactic sugar thing. So as you can see, withdraw and deposit, one of them uses a colon syntax and the other uses a dot with the self as a parameter. And then if you go down further, right here, you can see the way, well, right here, you can see the way they're used. It just depends where you place the variable pretty much. And that's the only difference. And besides that, everything's very standard. And my final example, critical to Lua as a concept, is C embedding. So I'm going to go ahead and show the code here. And basically, this is just the built-in API with Lua. You just have to do one install, which I have right here. At least that's for the version that I have, which I can see via Lua C-version, my version. And these are just API calls. I simply compiled my C++ code after writing the needed functions. And really all it's doing is communicating data between the two. So since it's already compiled, I can go ahead and run. And I can see that Lua received, Haskell is not fun. And then Lua sent back, Lua agrees. And then down here is where the function do math is called from Lua to C, and it does the math that C asked it to do. And the cool thing about this is since Lua doesn't use a compiler, I can go ahead and change the do math function, call this again, and then now instead of addition, it does multiplication without having to recompile the code, which is great for any C or C++ larger projects where compiling code might be a huge task regardless of having a makefile or CMake or whatever. But yeah, this is a pretty cool aspect of Lua, and I'm definitely going to want to play around with this more. But that's pretty much it for the programming language Lua. There's a lot more cool features that I've already ran over the time and not able to show, but I highly recommend using Lua, and I plan on using it sometime with C++ because it seems great and fun. So yeah, thank you for watching. Good luck with the finals, guys.